the very first question of the day. We have been dealing with exponents, and most of our questions have been about simplifying exponential expressions. And in order to simplify, we have been using the laws of exponents and some of the definitions. Now, I want to know from, before I give you this question to do, I want someone to share their thinking about how they would approach this problem. I don't want the answer, but I just want a sense of how would you think about going on this journey? And I'd love you to raise your hand so I can just hear from you. And then I'm going to let everyone have a go at the question. Okay, so can we unmute Sia? I see Sia's hand is up there.
Yes, we can.
Afternoon to everyone. Hi, sir.
Hey, Sia, what were you thinking about? What's your thinking about this question based on the last lesson?
So I'm not sure if I'm 100% correct, but I would think, is it possible to swap the 4 and the 3 for them to?
Okay.
Mr. S?
Anybody else? Does anybody else have an idea about how we can approach this problem? Or maybe it's my internet connection. I don't know.
Yeah, I think we lost you for a bit there, Mr. S. But
oh, sorry,
Sia.
Sia, I think it was me, not you. Okay, I see Philly's hand is up. Philly, what do you think? What approach what's your thinking for this question? How would I simplify this? Can you?
Hello,
Philly
sir.
is not oh, there we go.
What do you think?
So I think it take bring the 4 negative minus down.
Okay.
Yeah.
Okay. Awesome. Okay. Thank you, Philly. So there's definitely going to be a period. What Philly is noticing is that there's a negative power. And in order to make that negative power a positive power, we can bring it below the line. And then it will become 4 to the positive n. Okay. So now that is true. However, if I'm looking at this question, one of the biggest problems is I can't use the laws at the moment because all the bases are not the same. Like the base over here is 6, the base over here is 4, and the base over here is 3. And so for me, that is the biggest problem. So I want you to think about how can you solve that problem to simplify this? Okay, so let's have a look here. Annie, what do you think? Can you hear me, Annie? I think you're unmuted. If you can hear me, or you can put it in the, if you put it in the chat, I can read it. What do you, how do we deal with this problem that the bases aren't the same? Amanda, yes, we can break it down. So I'm going to suggest what I do is I put brackets in all the places where I want to break things down. So for the 6, I'm going to write that as 3 times 2. And then the 4, I'm going to write it as 2 times 2 or 2 squared. Now, the other stuff that was already there, the 2m was there, and the minus m was there already. So that's the first step that I would do. And then on the bottom step, I'm just going to leave it as it is for now. And what that means is now all my bases are at least 3s or 2s, which is helpful. Okay, that was a very good tip. Now, the next thing I need to do is I need to break apart these things inside the bracket. And I'm going to use law 3. And the way law 3 works is if you've got powers for numbers and you've got powers outside the bracket, you simply multiply the 2 powers together. So what I'm going to get is 3 to the 2m, 2 to the 2m. And what's happening there is I'm just multiplying this by this and this by this. And then over here, I'm going to get 2 to the minus 2m. So that is this being multiplied. And then on the very bottom, what I'm going to do is I'm going to multiply the m by the 2 here, and I get 2m. Well, let me actually leave it in black like this. So give me a thumbs up if you followed that second step. So I want to say it like this is step 1. That's step 2. Give me a thumbs up in the chat if you followed my thinking so far. Okay. Now, this is where we're going to get to that point that came earlier, is that we've got these negative powers and we've got all sorts of things going on. But the good news is all my bases are either 3s and 2s, and I spot something in particular. I spot that there's a 3 to the power of 2m on top, and there's 3 to the power of 2m on the bottom. Now, there's 2 ways I can do this. The one is to say anything over itself is 1, okay, and just cancel them out. Or I can bring this 3 to the 2m to the top, and it's going to become 3 to the minus 2m. Okay, so that's probably the way that most of you would do it. So that's like that. And then we've got bases that are 3 and bases that are 2. And so all I'm going to do is the base is the same. So I'm going to add the power. So minus 2m plus 2m. And then for the 2, it's going to be 2m minus 2m. So all I did was I moved this to the top, and it went from a positive power to a negative. And then I looked for bases that were the same. So this base was the same. So you'll notice that it's there. And then this base over here, and then I added the powers like that. I want to know in the chat, what is the final answer? What is the final answer that I get for this? I'm not finished yet, but Sino, why do we move the 3 to the top? You don't have to move the 3 to the top. There is another way of doing it, which would be canceling out the 3 to the 2m on top and the bottom. But I just made that choice because I thought most students would do this. But we'll get the same answer in the end. So let's see what people put in the chat as the answer for this question. So minus 2m plus 2m is to the power of 0. 2m minus 2m is to the power of 0. So what is 2 to the power of 0 times, 3 to the power of 0 times 2 to the power of 0? It's just going to be 1 times 1, which is 1. So the final answer of that whole fancy thing is just that it's equivalent to 1. Now, in a moment, we're going to do a very similar example. Are there any questions about the steps that we've done so far? I just want to give a moment for questions. Because that was sort of like round 1. And now we're going to practice a similar problem in a moment. Just want to give a moment for any questions in the chat or okay. Cool. Okay, let's have another go. Let's see if we can do a question. So if I look, there's a little like cheat sheet here. In fact, we'll look at that afterwards. Let's look at the question first. You can always read the cheat sheet if you want, but see if you can start to solve this problem. And I'm going to give you 2 minutes to work by yourself. If you get very stuck, then I want you to raise your hand and we can have a little conversation. And there is a little cheat sheet over here to give you some tips that you can also read, but I want you to try and fly a bit more solo. So let's go. Over to you guys. Get some water. Hmm. Kutsadzo. Let's unmute Kutsadzo and we can get a question there. So,
Hi, sir.
what's your question?
Sir, I'm stuck at do we first use the brackets first? Do we first break down the brackets or
Yeah, that's what I would do. And the reason is that none of these bases are the same, right? So because the bases are different, you can't use the laws of exponents like we normally would. You have to break them down into smaller pieces. Now, the only one that's a prime number is 3, right? So 3, you can't do too much about. But 27 and 9, I think you can do something about.
yes?
Okay. I'm going to suggest 27 can be written as 3 times 3 times 3, or 3 cubed.
Yes.
And 9 can be written as 3 squared. Okay, but now there's still more to go on the journey. So let's keep swimming and see where we get.
Okay, sir.
Once you think, I forgot the x minus 2. Oh, thank you so much. You are such a help. So I'm going to put that in like that. Well spotted. Oh, it was labeled. It was you. Oh, you well done.
Stealing the kid's job.
It's there's a lot of things going on there. And it is easy to leave things out, as you can see. You need to be careful. So once you feel like you've got the answer, pop your answer in the chat and we'll see how it goes. We've done this step. Now, what we need to do, the thing that strikes me as being a bit messy is this bit. Like, we need to deal with these bits. And I want to suggest that that part is easy, but this part becomes like that. And this part becomes like that, which is starting to get a bit tougher. And then once you've got that step, what do you think I'm going to do next? Who wants to give me a tip as to, so step 1 was bases. Step 2 was to basically multiply out the powers. Now we need another thing. Okay. I saw a hand. Someone's hand up there.
Oh, they put it down.
Yeah. Let's
Oh, there it is again.
Yeah. What do you think we're going to do next? And there's different ways to do this. Hey? It's not one way.
Hi, sir.
Hey. What do you think?
I think we're going to add the exponents because we have the same base now, which is 3, and we're multiplying. So we're going to add the exponent.
Perfect. So on top, would you agree with me? We get 4x minus 5. Would you agree with that? Are you happy? X
Yes,
plus
I'm
3.
happy.
Okay, now I'm still stuck though. What do we do about this stuff down here? Any ideas? It's a tough one. It is a tough one. You want to phone a friend?
And we have Annie.
Okay. Thank you. Annie, yeah, let's go to you. What do you think we have to do here? Can you hear me, Annie? Okay, I don't know. Maybe there's an audio problem with that. There's two ways you can do this. I think the easiest way is probably to bring the stuff from the bottom to the top. Sounds a bit like a rap song, doesn't it? Hey? But what we're going to do is we write that, and the one that comes to the bottom, its sign changes. And so that becomes minus 4x plus 8. So notice how everything that was positive becomes negative, and the minus 8 became positive. You can also do it another way, but my experience is that students forget when they do it like this. When they subtract the powers, they forget that you have to do a bracket like that. So you can also do it like that, but my experience is more things go wrong when you do it like that. Whereas when you move it to the top and you just change it to the opposite sign, now we're back on just multiplying, and the powers, well, the bases are the same. And so what we have now is we go 4x minus 5 plus 8. So what's my final answer going to be? I want to see in the chat. What's the final answer going to be? I'll zoom out a little bit or zoom in.
Keep those answers coming, guys.
I see. There we go, Sino. There we go. Keep them coming. So the final answer is going to be 3 to 3 or 27. Okay. Nice, boy, Timele. Nice, Timelo. Looking good. Looking good. We are showing. Now, this is straight out of grade 11 test 1 for the year. Hey? So once you bank this, you are taking those marks to the bank. So I want to squeeze in one more question before our break. And so what I'm going to ask is that we start having a go at simplifying this question. I will leave the other one on the board for you so that you have a little bit of a reference frame. But I want everyone now to try and simplify this question over here. Okay. And use the techniques that you've just used. I will leave the previous question on the board so that you have sort of a rough guideline to help you. And then if anybody is feeling very lost or stuck, don't be afraid to raise your hand and we have a chat while some students are busy working on it. Okay. That is the very nice thing about the internet and being like this, is that you have a lot more flexibility to ask questions. So in Zalo, what we're doing is we are trying to simplify. So let me put the keyword here. The goal is to simplify this exponential expression. And we say exponential because there are lots of exponents and bases. And when we deal with exponents, we really like to have prime bases or we break the bases into their prime factors. And so what we're trying to do in the step 1 of this question is break the bases down. Now 5 is prime, so it can't be broken down further. But 9 is not a prime number, and so it can be broken further. And 15 can also be broken further. 3 is a prime, so that can't be broken further. So your first port of call is to ask yourself, what is 9 and 15? What can they be broken down into? I think that's 3 squared, and then this is 5 times 3. So that's step 1, and now we're trying to figure out how do we simplify the whole expression. Once you've got your answer, whether it's wrong or right, I don't care, just put it in the chat as best you can.
Keep going, everyone.
We believe in you. Let's have a look here. So the next step that we had to follow, what we're using law 3 here, where you have powers inside and powers outside. And we get down to the stage where 5 and 3 are our bases. And what I'm actually going to do is I'm going to move basically everything onto one line. And so if I do that, now you could cancel out these 5 to the 2 ends. I understand that's not a problem. You'll get the same answer, but basically this moves up to the top, and then 3 to the 2n becomes 3 to the minus 2n. And then that was 3 to the n, 4n minus 6. And then this becomes 3 to the minus 4n plus 1. You don't have to do it like this. So that's 5 to the 0. Now we need to keep track of this. We've got 4n minus 4n, so that's fine. And then we've got a minus 2n. And then we've got minus 6 plus 1, so we've got minus 5. So all I'm doing is adding the powers, and that means I have 1 times 3 to the minus 2n minus 5. And when we deal with exponents, we really like the powers to be positive. And so if I move this below the line, I get 3 to the power of 2n plus 5. Now, it's not the only way to do it the way I did it, but I think on average, most students like this idea of moving everything to the top. There are many other ways to do it, but as long as you got that answer, you are fine. So 3 to the power of negative 2n, negative 5 is also correct. It's just that often in these questions, they like you to leave your answer with a positive power. And so this is correct, but then I just moved it below the line, and you'll notice that it became a positive power now. Now, we're not perfect yet, I know that, but I think that we are getting better each time we do this. So just give us a quick thumbs up if you feel like it's starting to make sense. Thumbs down if you're feeling very confused and very lost. I just want to get a feel for the general sentiment in the group. I know obviously people who have just joined late or for a moment, you'll feel a bit confused, I'm sure. Remember, this is all recorded. Okay. Then, ladies and gentlemen, we have earned a break. So what I want you to do is I want you to turn on your cameras, and I want you to stand up, And I want you to join me in giving yourself some time for your brain to click save as. Okay, so we know that our brains don't want to sit for too long. Let us, for a moment, stand up. I want to just make sure I see your pictures as you join us. Oh, that is awesome. And what we're going to do is, can you see me? I suppose it's easier if I see
Yes, we can see Mr. Is.
Here we go. All right. So we've done half an hour, so we're going to pat ourselves on the back. Well done. You have done well. There we go. Pat yourself on the back. Well done. How does that thing go? Anyway, so we do that, and then we're just going to roll our shoulders quickly. And your body's like, oh, thank goodness, I can stand up. So just roll those shoulders. Oh, doesn't that feel good? Doesn't that feel good? Roll those shoulders forward. And give yourself a little bit of room to swing your hands around. There we go. Sometimes I think the primary school kids have got it right when you see them running around the field at break and you see them spinning around. I think there's something to that. Okay, let's just quickly stretch our triceps. There we go.
Having this participation, shout out to Orikonisa, Kudato, Sia, Mbali, Afeziwe, Mangaliso, Annie, Oisa Malebu, Pitumela Nzako, Bonga, Karabo. Awesome, guys.
And then just do one more stretch like this. You might hear a few clicks. Oh, goodness gracious. And then just shake it out again. Let your body get nice and loose, nice and relaxed. There we go. Doesn't that feel good?
Doesn't that feel refreshing? Yes. I'm so energized for the second half.
I know my body feels a lot happier with me. And the other thing is that your brain kind of, it just stores things better when it's relaxed as well. So we know it does help us with the maths too. Okay, so here is the brain break question for today. You need to tell me what a biscuit plus 2 bananas times a different type of biscuit is. And once you've got the answer, you can put it in the chat, or you can raise your hand and let me know how we did. So common sense tells me that if there are 3 of these and they're 30, each of them must be 10. So no surprises there. But now be careful because there's 2 bananas in this row. And if there's there's actually 4 bananas in total, plus 1 biscuit of 10 gives me 14. This has to be 1, 1, 1, 1, 1, 1. And if that is 2, and then I add 2 more of these to get 8, I think you'll agree with me that this is 3 and this is 3. Okay, so now we've solved the numbers, but now we have to think of this thing called BODMAS. And BODMAS says multiplication happens before we do addition. So we have to do this part first before we do that part. Now, if you want to vote with your answer, let us know now. But for me, what I see is 3 plus 1 plus 10, because 1 times 10 is 10. So our final answer should be 14. Okay. So I see lots of you got close to that. Now, but you'll notice that we do these questions a lot. They're actually called simultaneous equations. where one piece of the puzzle feeds into the next piece. So you had to sort of solve for the brown biscuit, then you solved for the banana. And what was sneaky about this one is that they had 2 bananas in row 2, but then they had 1 banana later on. Okay. But I liked what I was seeing in the chat there. And yes, well done. Well done, Offense. Practice makes perfect. Yeah? The more you do these, the more your brain goes, oh, I see the structure that I need for this question. And this is actually a preview of a topic we do in grade 11 in algebra called simultaneous equations. So you're even learning maths when we're having fun. Okay, give me a thumbs up if you're feeling good. Give me a thumbs up if you're feeling ready for part 2. If your body is recovered, I like it. I like it.
Our people are ready for more.
Okay, so what I'm going to do now is I'm going to slightly change. Maybe I should do one more. Actually, let me do one more of the other type of question. Let me go and grab this one, and then we'll move on to the other type. So I want you, have we done this one before, everyone? Don't think we have. I want you to try and simplify this expression for me. So simplify this expression. I don't think we've done it before. Let me know in the chat if we have. I want you to try and simplify this exponential expression for me.
Go for it, guys. Mr. Ace?
Yeah.
Ayanda asked if it's possible to take a screenshot of the previous question.
No problem. Let me, oh, sorry, that's a bit too much zooming, isn't it? How about I just leave it like that? And you can kind of see both. Oh.
Thanks, Mr. Ace.
Cool. So the step that I've done is the step where we break the bases into their prime factors. That's the fancy way of saying it. So 2 is a prime number, 5 is a prime, 11 is a prime. The next step is applying law 3. So powers get applied to powers. And so sometimes I write like a little 1 in there just to remind me, oh, there is a power there. It's just a 1. Okay, so one of the things that I wasn't doing earlier, but you can do in that it will save you time, is that instead of, if you recognize early enough in the question that 11 to the n plus 1 on the top and 11 to the n plus 1 on the bottom, anything over itself is 1. Now, earlier on, I was moving it up to become negative, but it is quicker to say, look, this cancels out with this, because those things are exactly the same, and that's going to give you an equivalent of 1. And the reason that can be a good strategy sometimes is it just gets really cluttered if it's nice to be able to take something out. Okay, but it's also fine to bring it to the top and it become a negative n plus 1, you'll get the same answer. So now what I'm going to do is I'm going to bring the 2 to the top, so minus n minus 1. And then I had 5 to the n plus 5, and I'm going to get 5 minus n minus 1. And you have to be very careful that your powers don't miraculously misbehave. I've had this happen to me a couple of times already. So notice how when the n plus 1 was on the bottom and it suddenly appears on the top, it's negative n minus 1. And then the final answer, let's see what we can do here. We write down the 2 and we get 2 to the 4. And then here, what we have is we have 5 to the 4, which is going to be 8 times that. So the final answer is going to be 10,000. The other way, you could also go backwards. You could just go, okay, this is a little bit sneaky, but you could write it like this. And then you get 10 to the 4, which is 10,000. So it's kind of using law 3 in reverse. All right. I like what I'm seeing in the chat. And so I'm just going to give you a second to just check the answer. And then we're going to finish the lesson with a different type of question that we will continue in the next lesson with. So you've done very well on this type of question. And I'm pretty happy with it. But now I want to show you one other variation that requires a slightly different treatment. Okay, so let's look at this different type of question. Take a screenshot if you need to of the working out for the one I've just done. I want to take you into this next type of question. Okay. All right. Oh, that's awesome, Inzalo. I'm glad to hear that. You know what it is? Understanding is just about practice. And you just keep practicing until your brain kind of goes, oh, yeah, I've seen this before. And then you're good to go. All right. I want to know from you as a class, if I said to you, simplify the following expression, how is it different to the examples we've done so far today? There's something quite different about this example. And I want to just know, first of all, what is different about this? You can put it in the chat or you can raise your hand, but what is different about this compared to the last one? The minus sign. Yeah, it has more than one term. Oh, you guys know this stuff. The top line is not multiplication, it's subtraction. And the problem is, because we've got separate terms, we need to have a different method to deal with this, because when the laws of exponents are normally valid for when we're multiplying like two things together. So, if you have 2 to the 3 times 2 to the 4, it's easy to go 2 to the 7. But here we're subtracting. And so we can't use the technique we've been using so far. So what do we do instead? We use another technique called factorizing to help us. And factorizing helps us to write this expression as a multiplication. And so we look and see, can we split these apart? And are things, oh, you guys know this. Okay, so if we take 2 to the x plus 3, I think that I can use law 1 to split this like that and like that. So just give me a thumbs up if you understand what I've done there. I've almost broken apart this bit over here. Give me a thumbs up if you understand that. And what I notice is that when I split them apart, okay, so 2 to the x times 2 to the 3, if I put them back together again, can you see how I would get 2 to the x plus 3 again. So it's almost like I've rearranged it to make life easy for me. And the reason I've done that is I noticed that there is what's called a common factor of 2 to the x in both of the terms on top. And so what we do in this method is we say, what is the common factor? And we take out the common factor and we open up a bracket. And then on the bottom, it stays like it is. So I've taken out the common factor of 2 to the x. And now I ask myself, what goes inside? And what goes inside is whatever is left behind. So what's left behind? It's just going to be 2 to the 3. Now that 2 to the 3 was just this one over here. And then what is left from the other bracket? It's just going to be minus 2. Okay, so for those who are feeling unsure, don't worry. We're going to carry on in the next lesson. This is just a preview. So step 1 of this was, in fact, we'll even do an example before. How much time do we have left? Okay, I'm going to do this example and then we'll do another one after this. So step 1 was to break apart one of the terms so that we could see a common factor, and that common factor was 2 to the x. So we took it out. Then we opened up a bracket, and in the bracket, we put what is ever left behind. So you can see now if I multiplied this out, I'd get 2 to the x plus 3, which is what I started with. And then the other part of the bracket is here. Now what I can do is the following. If I see 2 to the x over 2 to the x, anything over itself is 1. So that cancels out. And then what is 2 to the 3? It's just going to be 8. And what's 8 minus 2? It's just going to be 6. Slindokughle, you are absolutely correct. So this new technique, what do we have to do? We first had to recognize that it was no longer multiplication, it was subtraction. And then we used factorizing to, well, we first broke it apart and then we used factorizing. So take a screenshot if you need to, because now we're going to do another example just to help us get more comfortable with this. I want those who are feeling comfortable to try and simplify 3 to the x plus 1 plus 3 to the x. Notice how there's no multiplication. And I want to see, can you perhaps think about how could you use the technique I've just showed you to help simplify this one? And the problem we have is it's not multiplication and division, it's addition. See what you can do there. I want to suggest that in the first question, our first step was to break down. Now, what would we want to break down? I think we want to break down this to that. And then we ask ourselves, of these two terms, what is the common factor? See if you can get the answer from here. So what did we do above? We found the common factor and we took it out. And we ask ourselves, what is going on inside the bracket? So we're now going to get what's left behind. We have 3 to the 1. Now, what's a little bit sneaky here is there is a phantom 1 sitting in front here. Because what do we need to multiply by to get back to 3 to the x? We need to multiply it by 1. So be careful. That we'll practice this in the next lesson. We'll start with this. So where do we go?
Mr. S, I think we lost you there. Mr. S?
For the next lesson.
Can you hear me, Mr. S?
I can, yes. Sorry, did I go away?
Yes, you were away for a bit.
Okay, so all I said was you don't need to worry too much about this particular example, because in the next lesson, we're going to start with that. This was just a promo for the next lesson. Okay,